Hello everyone. In this session I'm going to show you how to use ziotest. Here is a project which already has a test using spec2 library, and this code base is using Zio. If you are interested about the detail of the implementation, you can check out my talk in LambdaConf and in Scala in the City. And I also will add the link for the repository to see the whole code, and yeah, you can check it out. And in order to be able to use specs with Zio, we had like the test runtime, which is a helper to interact with interpreter of Zio. But now when we are going to use ziotest, we will not need this anymore. It is like when you see this, it sounds quite complicated, and like I even forgot what was happening there. So let's not look at this, because we will remove it. I can remove it from now. And also this, don't be confused, there are two version of the code. I can refactor the code better. Maybe, okay, let's now refactor it. V1 and add this, because there was two solutions to explain. If you are interested about the different solutions, it's not very different implementations, but the second solution will solve the first one. So you can check out the talk, and you can understand more in detail about it. So to not be confused, let's do this. And for sure it doesn't work because we removed this. And we will, let's for example choose the version 1 to, let's update the first version, and yeah, of the code. Now the first step to start using ziotest, we need to add the Zio version, because this project already is using an old version of Zio, and because we will use this to add the dependencies of ziotest. And we remove this. And we can add dev.zio ziotest with this version in the test, and we can add ziotest sbt in order to add to the test framework. That's to be able to run ziotest, the tests using sbt commands. And now we are ready, so let's update the project and go to the specs. The first step is to make our test as an object. So once we will call test only this spec, it would be executed, and using default, we extend default runnable test. which requires to define a spec and default runnable test. Why? Yeah, it has, maybe it still doesn't know. I don't know. Let's see why. Sweet. We need to import ziotest suite, but because we will use the tests and assertion, assert, etc. So let's import the whole thing here, and we add the title and test. And it depends. If we are going to test the pure value, like for example search here, you're going, the first test is to test search, and search closest, sorry, and search will return an option of int, so there is no IO, so we can use test. If our function that will return an IO, we need to use test m, but now in our case we don't need to call. Let's copy all of this and just replace this assert with assert, and here must be some, it should be is sum and equal to this is sum. You need to import ziotest assertion underscore, because we will use equal to also, and we would, okay, the and is and there is something wrong, we will figure it out. Let's just do this, is sum. We have an assertion in is sum because to make it easier for us in case if we want to check, for example, that the value of this option, for example, we want to test is if it is a subtype of, for example, user or something, we can do different assertion. Yeah, is subtype, I think. Yeah, is subtype. To be able to test and to use assertion in is sum method, you need to have an assertion. This is why there is equal to. If you say, oh, why I didn't use like directly the int is sum of 0, there is a benefit to use an assertion here because you have more other options, like in case you don't know exactly which value the sum has, but yeah, the option has, and then you would like to check to make sure that it is a subtype of this class, or it is greater than that number or anything. So you can pass your assertion inside this sum, which is I really like. Assert, I feel like I'm doing, maybe there is something wrong, we will see. Is sum equal to 3, because maybe there is a parenthesis. Assert S3 is sum equal it's really yeah, it should work. Okay, is let's finish this and then later we will figure it out. Is sum of equal to 2. What is happening? It seems there is something. Yeah, it is using the correct. Oh, I didn't update the. It's not updated to the new version. I don't know. Oh, I left it with the oh, sorry about it. I will not repeat that video with this new version after this. No. Sorry about it. Okay. Let's wait. Now it starts to be happy. Nice. So, and for the second test, we are going to do the same. Here we do test step, and let's remove this to not be confused. And assert, okay, assert this equal to, oh, equal to and test. The step also return a pure value. This is why we needed to call test and not test m. The step will check if we remove the elevator. Oh, the elevator is moving to the next stops, and now in this case it will test elevators that doesn't have next stops. It should be the same. It should. I think we don't need this. We can say assert this, and we say equal to elevators. And okay, let's remove the things that we already done. Yeah, we already have done. I don't know. Okay, now comment this. Let's check our test if it is working before making more test cases. Okay. Test compile normally, but let's check also if because we updated the version, maybe the code is there is something No, because the code is not using a Zio environment or something that has been changed in the new version of Zio. Test compile. Oh, yes, I should comment the whole test because now we are not using specs and we removed that to our dependencies. Nice. Now let's execute our test because we only have that test, and because I'm lazy, let's do test. Otherwise we can call test only, and now it works. And if you would like to check it doesn't work or something, let's, for example, we need to make sure that the elevator states should be exactly equal to this and not keep the order. The order is the same, but let's say that we change the order. This test should fail. Yeah, and if we don't care about the order, we can use has same elements and it will work, but actually we care about the order in our case, so it's important to make it to test it with equal to. And now let's test the request. Here query the state of elevator, and I think this will return an effect. The request needs let's uncomment the test case that we want to copy. Yeah, it is this query. It will fetch the state, and the state, the elevator, is a ref, which is a data structure built on Zio, and this will return an IO, so we need to call test M. And we can copy paste the whole thing here, and actually because we have only this, let's do assert M and elevator system of elevators dot flatmap dot query. This should be like this, should be equal to elevators. Even this is an IO. Assert M will take care to run this effect and to test, to assert that its produced value equals to this elevators, which is the same as the input because we didn't have any change in the state of the elevators. Nice. Now we can remove this and let's test again. Nice, it works. And yeah, request. The request, okay. Now we test that, send in a request, and for sure it will return an IO because it's an effect to interact with something that will store the requests of the elevator, of the pickup passengers requests. And actually, let's copy paste and then. Actually, I didn't like this name as request. It should be send requests. And okay, here we want to test that in the beginning there is no requests. The size before should be 0, and once we send the request, we test that there are there is now one request. Let's do assert size equal to 0. And assert size after equal to 1. Nice. Now let's remove this and remove this. Test. Awesome. Now for run test, and this run, it will execute the test, the app that we expect. It will really interact with, it will run the elevators, move the elevators concurrently, and process the requests. It is an integration test for this. It's like this test needs to be two parts. We need to have like two tests, one for this like functionalities, to test them one by one, and for the run it should be as defined as an integration test. Send request. And this actually quite complicated. It's because we send requests concurrently and execute the elevator, which will move the elevator and process the request in parallel. And this will be like move the elevator every 1 millisecond and process the requests. And this is like, I don't like this. But let's just not think to, because it needs really to be improved. But let's just use the current implementation. And here, let's remove this parenthesis. When we see here, for example, we make sure that the whole requests are performed, which it is only one request. We send one request and we make sure that that request is performed. We wait until the size is less or equals to 0, because the requests are stored in a queue, zio-queue, which is a bounded queue that uses the back pressure strategy. And in case if there is like here in run, the requests will be taken and this action will be repeated forever. So in case there is no request is common, when we do request.take, the size would be -1. And we should catch this. Like once we found out that request has been performed, it could be equals to 0, but we might arrive to this point in time. Maybe this would be quicker than we expect. Let's remove this. I really don't like to sleep. Yeah, this will make sure that this request has been performed, and also we make sure that the stops, there is no next stops. And the final state, we should make sure that the first elevator has the destination of the passenger, and the second one also has the destination of the passenger. It's like the whole thing is processed. But actually, when we execute this test, it will not work. I will tell you why, but let's see how this will be blocked. And it says it suggests to use test clock adjust because ziotest by default uses the test clock environment that we need to adjust. We will have control over the clock. We can say, for example, if the run will repeat an action every 1 millisecond, the test will think of itself that I am still, there is no time passed. It's like you need to move the clock to say, okay, now there is 1 millisecond already. Like, for example, if we adjust the clock that 1 second, we say test clock dot adjust 1 millisecond. If we say 1 millisecond, the elevator will move only 1 step because only 1 iteration will happen, because when it tries to repeat, the clock will think, okay, now I have 1 millisecond, I can move forward, and then it will block because it will wait for the time to pass, and we didn't increment the time, and so it will just stop and wait. It thinks that I am always in the present, and the present will not be moving. I don't know how to express this, but I think it is clear. And when we do .second, for example, at least we don't have a lot of like the steps would be like here it would be 13 steps, and here only a single step, so like it would be sufficient. And also we have 1 second, it's a lot, but it's fine, we give more time, but we can do 100 milliseconds, for example. And now the elevator will move and think of itself that I am in the future and I can go forward. Let's do this, but actually I wouldn't do. I will tell you what after I will run this. Yeah, now it works. But I would prefer, in this case, to use the real clock and to make sure that the production code is working as expected using the same environment as the production environment, which is the clock.live. How could we customize the environment of the test? How could we tell this test case to use the live environment? We can provide custom layer of clock, which is, I hope that it will be suggested. Okay, I will help. No. Okay, let's do zio.clock. And live. Oh, it should work. Yes. And here, now without adjusting the clock, that test case will be executed using the environment, the live environment. Now we have a clear picture what would happen in production. So this is our integration test. But sorry that everything is put in the same file. Now it's the same for the other functions. I think I could I think I could do them, copy paste them, and be quicker. Now I copy pasted everything. It was the only difference that, okay, we use it equal to, and here if you want to check if it is less and or equal to something, you can use this method. And also in case in general the tests are running in parallel, and if you would like to make them executing sequentially, you can import ziotest test spec2.sequential, and you can add sequential, and this will make it should be in the whole test suite, and each test case will be executed one by one sequentially. And there are many other things in ziotest. You can discover them. And for our test in run, as I told you, it's like this is the integration test, how it is, how our system is working. And if we would like to check each step for the elevator, what is happening, etc., we are able to control this using the test clock, and we can adjust it every point in time. I expect this state, and we can do many things. We have really we have a control over our effects. Even they are running concurrently, we can adjust the clock and try until we find this the first step is that, for example, we test if that elevator is going one step up, and step by step here we can test many scenarios. But I hope that now you have a clear picture how to use ziotest. Thank you for watching, and see you soon. Zio!